one of the important theorem in set operations. It's Demorgan's laws. First, we have to review the symbols. So U here means union, and then the reverse of U, which the flip of U would be the intersection. And the apostrophe means complement. Okay. So in this case, the first De Morgan's laws says that A intersection of B apostrophe that's complement of this A intersection B is equal to the A complement union B complement. Okay, so let's have an example. So it says the complement of the intersection of two sets is the union of the complements of those sets. So if I have two sets here, let's label this as RU here. This is RA, set A, and set B. U means universal set. And then I will put elements inside that. So let's use K, L, and M. And then the outside, let's put B here. Okay. So if I'm going to take the first side of the equation of the first De Morgan's law, it says set A intersection of B. So what is set A intersection of B? That would be A intersection of B. So that would be L would be the answer. In there. So that's the common element for A and B. So when you say intersection, the common or the overlapping between set A and set B. And then the next one, it says the complement. So you're looking at the complement of A intersection B. The complement, it should be outside that L. And the outside of L there, the elements would be, looking at the example, the elements would be key or K, K, and we still have M, element M, and then element P. So this is the complement of A intersection B. Okay, now let's work on the right side of the De Morgan's. Okay, So what we're trying to do here is to prove whether this Demorgan law is valid or not. So we can use this in some of our calculation later. So A naught um, A naught would mean outside of A. So what's A is a K and L. So outside of A would be MP. So element M and element P. So those are the two elements outside A. And then we have B naught or B prime or B complement. So the outside of B would be element K and element P. Okay, and then the next expression would say a um, complement union of B complement. So when you see union, you just actually combine the two sets, the A complement and the B complement. So it will give you K, M, P. Okay, so they are just exactly the same. So looking at this on the left side of the De Morgan's law is equivalent to the right side. So this expression here, it's a valid expression. So that means that we can use that for a future calculation. So this is exactly the same thing also when we're trying to prove the second De Morgan. So you can use the same example. And that's the complement of the union of two sets is the intersection of the complements of those sets. So that's the proof for the De Morgan's law. So let's have an example for the set operations. Okay, so we did set operations involving the De Morgans a while ago. Now let's have another example. So given U means universal set, and we have here 1 comma 2 3. These are the elements inside U. And then A, set A, we have elements here 1 comma 3 7 and 9. Now for example, we're asked to find um, let's say number 1 here, A naught. So when you say A naught, it's the elements outside A. So you can actually just list it down. So we have 1 here, so 1 cannot be taken. So 2, we don't have 2 inside A, so we have 2 here, so we can have that. 3, we have 3 inside A, so we need to have elements outside A. So we can take 4, and then we have 5. We don't have 5 in A. And then 6. We don't have 6 in A also. So 6. We can take that. 7. We have 7. 8. We don't have 8. 9. We have 9. So 10. So those are the elements inside A naught or A prime or A complement. Okay, so let's add set B here. Say set B has 3, 7, 8, and 10. Then the second question would be, what is A union B? Or when you say what is A union B, we can actually have that and just add all of them, whatever inside A and B. So 1, we have 3, so there is a 3 on A and there is a 3 on B, so just list one of them. Okay, so that's the similar element. Then also with 7, and then we have 8, and then 9, and then 10. Okay, so that's A union B. So 1, 3, 7, 8, 9, 10. Okay, so if you're asked to find, um, we can just remove the parenthesis here because we don't have the prime yet. Okay, so or the complement. So on the next part um, of the question will be asked on the complement. Okay, so let me erase part of this one. Okay. So it's A union B prime. So what would be the answer? It's just looking at the answer for number 2. You're just looking at any elements that's not in this set, okay, from the universal set, which is the U. So 2, 4, we have 5, 6, 7 is already there, 8 is already there, 9 and 10. So that would be the A union B um, complement or not. So that's 2, 4, 5, 6. Okay. Next question would be, what is A intersection of B? Now, what you're looking at is just the common elements here. So your answer would be like common elements like 3. They are the common elements of A and B. So 3 would be our first element here. 1, there's no 1 on B. We have 1 on A. 7, yes, we have 7 on A and also in B. So that 7 goes to the intersection for the two sets. What else? Do we have 9? There's no 9, 8, and 10. So that's the one. So we have only two elements for the intersection. Okay. Okay, now the last one would be finding a not intersection of B not. Okay. Now, um, we just added our B here. Okay, from 1. So we started without B for that one. Okay, so our B not. So let's calculate our B not. B not would be, we write that on the side. B not, you have B there, which is 3, so we can write 1, comma 2, and then you have also 4, 5, 6 for B not, because we have 7 next. And then 9. 9 is the last one. We have 8 and 10, so that should be 9. Now, the intersection between A naught and B naught, so that should be the common elements. So I'll use a different color here. So we will have the intersection that would be 2. So that's the first element, 2 here, comma. And then what else? 4. So we have 4. Um, as the common element. 4 here, and that's for the intersection. Another one would be 5. Okay, 5. Then we have also 6. So 6 is there. Okay. Now looking at another element there, which is 9. 9, we don't have that in A naught for 9. So that would be our answer. Okay, for number 5. Okay, so let's try one last example, having 3 sets now. So you'll have U, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then our set A would be 1, 2, 3, 4, 5. Set B will have 1, 2, 3, 6, and 8. And then C, again we have 3 sets now. 2, 3, 4, 6, and 7. Okay, so now we're asked to find A intersection of B union C not. Okay, so um, we have to look at first the grouping symbol. It's like this is similar to PIMDAS. You work first the inner part of the expression. So we need to know first what is C naught. So let's write that out. C naught is equal to our actually answer would be looking at your U. Your C has a 2, but you don't have a 1, so 1 goes here for C naught. And then we have a 3, and we have a 4, and we have a 6. So 7. So 2, 3, 4, 5. So there's no 5. So 5 goes here. Okay, and then the next one, there's no 8 and 9. So 8 goes here and 9. So again, look at your U set. So whatever actually elements that it's not in C, in U, that would be your C naught. And then we have to work on B union C naught. So we're just adding the two. We already have our C prime or C complement. So for C naught. So that would be union. What's our B? So we have a 1, 2. We're looking at our B. Our B is here. So you can copy that 3, and then 5, it's in C naught, so we can have that in order. 5, and then 6, we have that in B. 7, we don't have 7. 8, we have 8. And then 9. So that would be the elements inside B union C complement. So next, it's the intersection. So we're working on this now. It's the intersection between the two sets here, A and the group B union C naught. So it's the intersection. It should be the common element. So we have to look at A. So A and this group. So A and this group. So we're looking at, let me mark this down. I'll just put circle in yellow. So I'm looking at A and this group. So, and I will write the common term. So the common term, the one that's overlapped each other for A. A is 1 there, there's 1 there, so 1 goes here for the intersection. The next one is you're looking at 2. For A, do we have 2? Yes, we do have 2 here. So 2 goes here. Next is 3, so we have 3 also, that expression. And then 4, let me see, we don't have 4 for that group. Then we have 5. 5 is here. So 5 goes to the intersection. So our answer is that set. So where's our answer for that problem? It is U or A intersection of B union C complement. The answer is the set with elements 1, 2, 3, and 5.